Can you all hear me?
Yeah, good evening, sir.
Good evening, Prasanga. How many more to come? I think we have 1, 2, 3, 4. Can we start now? It's almost, I was waiting till the others come, but let's start without waiting for long. So basically, what we plan to do today is actually continuation of this discussion that we had, right? There's one chapter that I'm doing, but still a little bit of a technical areas that we have here, so I can't do it very fast. So let me start from the point that we stopped last time. But before I start, any clarifications, any comments that you need to make with regard to what we have done so far? So let me share my screen. Did you all get the presentation which was shared with you? I think it was shared today, of course. Did you get it downloaded? Hello? Did you all get the presentation that was shared with you, I think through the e-learning portal? Yes? Hello?
Actually, no, my sense, because I check, I couldn't get it because maybe in the last minute they have uploaded. I don't know.
Probably, yeah, probably. But we want to add today's discussion as well into that. Okay, that's okay. But I will be explaining it through these slides. So let me see how fast we can continue, do this. Basically, these are the areas that we were. One moment, please. Right. Okay. So these are the areas that we have been discussing in the last lecture about the population sampling, what is a case study, what's evaluation synthesis, what's modeling, and then one moment. And then we were looking at what is in populations, what is a discrete variable, and attribute sampling in discrete variables, and continuous variables. We do variable sampling, and what is a normal distribution. And then, of course, an example of what is a discrete data, what are continuous data. And then what is the probability distribution of a discrete variable and the probability distribution of a continuous variable. And then the measures of central tendency, the indicative value for a range of values, a group of items, the mean, median, mode, what these items means, and then how to calculate them. And then in a normal distribution, what happens to the symmetrical distribution, mean, median, mode, how they are distributed. And then what is a skewed distribution, a positively skewed distribution versus a negatively skewed distribution, like this. And then about when we have a normal distribution, what is standard deviation, which measures the variability, and these percentages, the percentages and the probabilities where we said, okay, if we take the mean, one standard deviation above the mean and one standard deviation below the mean, 68% of the values are there, two standard deviations above and below, 95% of the values are there, three standard deviations above and below the mean, 99% of the values are there. So, and these things, and then 90% values are between plus and minus 1.64 standard deviations, like this. These figures we've just looked at. I gave you an idea. I will try to do a couple of questions today. But now I told you at that time, these percentages and these figures, you may have to have some idea, because these are very standard figures. So therefore, you need to have an idea with one standard deviation, two standard deviation, what are these percentages? You need to have an idea. And then that is. I didn't understand that. Just one moment.
Sir, you are mute.
Sorry, this is where we stop, and now we are going to move on to the areas for today's discussion. So this is where we are going to start our discussion for today. You can see my screen. Basically, now before I start again, is there anything that you would like to get clarified about what we discussed?
Yeah, I had a question. We talk about the positive and negative, that curve is going to
Yes.
negative and positive side. My question
Yes.
is, can it go up and down?
No, up and down in the sense?
Maybe sharp curve and the normal curve.
Okay, it's like this, right?
Yes.
Okay. Now if you take a curve like this, like, okay, can you just give me a minute whether I will see whether I can pick a slide to explain to you that, since you asked this question. One moment.
No.
If you give me a minute, I will just try and see whether I have another presentation, whether I can show that to you. No, if I had a graph anyway, I could have explained to you much clearly. No, it's like this actually. Now, say this is a normal distribution, right? And then you have a curve like this. This curve has a particular shape. You know, this bulk shape is there. So this shape of the curve is indicative of the distribution of the values. If the values are distributed very close to each other, then this curve is a compressed curve. You know, it's not a flatter curve, it's a narrower curve. But if the values are dispersed, then it is a broader curve. So if the standard deviation is low, the values are close to each other. So then it's a compressed narrow curve. But if the values are dispersed more and more, then it's not a narrower curve, but that's a more spread curve. So if the standard deviation or the variability is less, it's a narrower curve. If the standard deviation and the variability is more, it is a flatter curve. Is that clear? If the values are close to each other, it's a compressed curve, narrow curve. If the values are very much dispersed, it's a flatter curve.
Yeah, thank you, sir.
Okay, now I don't know to take your time here, but I had for some other program, I had very clear slides actually on that, because that's just a different curriculum, but I can't just, one moment just to see. See, it's like this. Say, can you see this presentation now?
Yes, go ahead.
Yeah, so see, you see this one, the narrow curve. This is a curve where the values are close to each other. The level of the values are very much close to each other. So then the standard deviation is less. So therefore the curve is like this. But the values in the individual values of the populations are more dispersed. So then it is a flatter curve like this. So curve like this, standard deviation is less and the variability is less. Curve like the second one, the lower one, the standard deviation is more If the values are not close to each other, they are much more distributed. So that's what it means. Okay, like this. See? By varying the parameters mu and mu, we obtain the difference. So it's a narrower, flatter and flatter. And at the same time, when the curve shifts to the right, so that means the standard, the mean value is higher. So don't go into that, but okay, I hope I answered your question. Okay, Ranga? Right. Okay, now we move on to this. Any other questions? Okay, now we will also have I will explain to you this further through a couple of questions. The confidence level is the percentage of time that a sample is expected to be representative of the population. This is something that you have to clear idea. Okay, what does this mean? Just read it carefully once. Just read it carefully on your own once, that highlighted area. So sometimes when we take a sample and we calculate the mean and the standard deviation, and then we will express a confidence level, right? We will express a confidence level, right? Now, when you say confidence level of 95%, that it means is there is a 95% chance that the sample is representative of the population. That is one way that you can interpret what a confidence level is. After we take a sample, statistically, if we say there is a given 95% confidence level, so that means we are 95% sure that the sample is representative of the population. Because when we take a sample from the population, unless we take a representative sample, there's always a chance that it may not be representative. Depending on with a large population, you take a small number of items and sample, and when we calculate a value, there is some chance that it may not be representative. So 95% confidence level means there's a 95% chance that the sample is representative. So that is the risk of taking samples as well, because sometimes we make a sample and decide, okay, this is okay, this is conforming, and the documents are properly authorized, but there is still a chance in the sample they may be conforming, properly authorized, but in the actual population it may not be happening, because you have picked randomly, you have picked a sample in such a way the item within the sample happens to be, they are conforming, but the population over there may not be conforming. So 95% confidence means there's a 95% chance that what you do, what you get out of the sample is actually representing what is happening. So that is what you mean by confidence level. The second one is sometimes we express a confidence interval, right? Confidence interval for a given confidence level is the range around a sample value that is expected to contain the true population value. The thing is this. Now, when we take a sample, we want to take the average value of a default invoice, for example, average value of a default invoice. And then when you do that, if you say a confidence level, confidence interval, if we give that, right? So that means within that interval, if we say 95% confidence interval is between 100 and 200, so that means this is the range around which the true population value lies. Population value will be always 95% confidence. If you say 95% confidence interval, so that means the true population value will be within that confidence interval. That is what it means. I will explain it to you through the question as well, because the point is that the things here, we are touching a lot of statistical concepts, but in a very application-oriented manner. So therefore, if I explain it to you through a couple of questions, it will be even more clearer. So about this confidence level, confidence intervals, after about a half an hour time, I will do a couple of questions which will be more practical, and you will have a clearer idea, right? Just keep that in mind about the confidence interval and the confidence level. So we will come to that again. And then also, there is another concept that we are going to touch here. Well, that is, I will come to that later. So we just touched upon that about the confidence level. We'll come to that here. The coefficient of variability. we also speak of a concept called coefficient of variability. The coefficient of variability is basically when we take two samples, right? When we take two samples and when we calculate the mean and the standard deviation values, sometimes you have certain standard deviation values and the means, but just because the standard deviation values are high or low, you can't sometimes come into conclusions because these standard deviations will come with different levels of mean. So therefore, we always calculate something called coefficient of variation. You don't have to worry anything about the calculation. But let us say these are some of the values. Let us say these are some of the values. 3, 5, 6. So these are some of the sample values in the values. So these values are 3, 5, 6, 4, 3, 5, 4. These are some of the values. So the average value is 4.29. Average value of all these values is 4.29. And you are not supposed to calculate the standard deviation, but the standard deviation of these values will be 1.01. So we have a mean of 4.29, the standard deviation of 1.01. So then we calculate a parameter called coefficient of variation, which is your standard deviation divided by the mean. Standard deviation is 1.01, the variability divided by the mean is 4.29. So when you calculate this coefficient of variation, it is 23.54 when you calculate it. Just get to know this is enough how to calculate the coefficient of variation. In the second one, the mean is 4.29, the CM value, these averages also happens to be 4.29, but the standard deviation is 2.81. So coefficient of variation will be 2.81 divided by 4.29. So it is 65% coefficient of variation. This means coefficient of variation is lower, means the values are close to each other. Coefficient of variation is higher, means the values are dispersed from each other. So that is what you mean by what you measure by coefficient of variation, right? So right comparison will be whether values are close to each other or dispersed is not exactly the standard deviation, but standard deviation as a percentage of the mean value. So that is the coefficient of variation. And when you look at these values also, can you see these values and the second set of values? Which values are closer to each other? These are different distributions. This group of values, another group of values. Which group of values are close to each other? The first group of values or the second group of values?
I think first one, no?
First one, obviously. These values are close to each other. So that is why even though it happens to be the mean is the same 4.29, but here the standard deviation is low, here the standard deviation is high. So that obviously standard deviation also gives you some sense, but the right comparison will be standard deviation in comparison to your mean value. So this coefficient of variation 23.54 is lower than 65, means these values compared with the mean value are more closely distributed than in this distribution. That is the common sense visibility as well. So just have that idea about the coefficient of variation and that would be enough. Is that clear? You're not supposed to know about these calculations for this course. Are we okay? Can I move on?
Yeah, go ahead.
Right. So then let me move on to the next concept that you are going to learn. This is about statistical sampling and non-statistical sampling. For statistical sampling, the term statistical sampling explains what it is. But when you say non-statistical sampling, we will call that judgmental sampling. Right? So very broadly speaking, there are two approaches to sampling, statistical versus non-statistical sampling. That's number one. Now, what you mean by statistical sampling is when you pick the size of the sample. Let us say you had 10,000 invoices or vouchers that you are going to choose. Out of that 10,000 invoices, are you going to choose 100 invoices or 200 invoices or 500 invoices? That is the sample size. That is one decision that you need to make when you take a sample. What is the sample size? Second decision that you're going to make is how exactly you are going to pick the sample, right? How exactly are you going to do it? We are going to discuss that later, purely randomly whether you are going to choose them or are you going to use any sort of very specialized technique. So like that, there are different ways of picking the sample. So which items to choose and how many to choose, if it is based on a statistical concept, we call that statistical sample. But if that is not based on a statistical concept, but if it is to base purely the judgment of the person who is taking the sample, we will call it judgmental sample. So conceptually, there is a difference between statistical sampling and judgmental sampling. Okay. So this is what it means. The judgmental sampling uses the auditor's subjective judgment to determine the sample size and the sample selection, number of items, and how to choose those items. So it is purely judgmental based. There is no statistical tool, technique, concept that is used. This subjectivity is not always a weakness. The auditor, based on his experience, is able to select a test and test only the items he or she considered to be the most important. So just because it is not based on a specific statistical technique, but it is purely based on the judgment of the person who is going to pick the sample, it doesn't mean, right, it is a bad sample. Right? It doesn't mean that always when you use the judgment as against a statistical approach, the judgmental samples are not always bad, right? Because here what happens is the auditor, if he's a very experienced auditor, then he or she may use his judgment, right, more effectively to pick the right sample. So it is not necessarily be the bad case. Sometimes it can even be better and even more efficient approach. But at the same time, the process can be less expensive. When it is judgment sample, it can be less expensive and less time consuming, right? Because sometimes if he is a properly experienced person, rather than relying on statistical tools and techniques, he may use the right judgment, right? And then you don't need sophisticated statistical tools, software, experts, nothing. You use the judgment to pick the right sample and no special knowledge of statistics and no special statistical software are required. But that is an advantage of judgmental sample. On the other hand, the auditor has greater discretion to use his or her judgment and expertise. Thus, if the auditor has substantial experience, no time is wasted on testing immaterial items. Because when it is statistical, you do it little bit of in a mechanical manner, right? Because you follow the guideline. But when it is non-statistical judgment with a proper person, right, they can use the judgment, right, choose the items what based on his expertise. Actually, the items that need to be checked, he picks based on his expertise and the experience. Okay, so that is a good side of judgmental sample. On the other hand, disadvantage of judgment sampling is that it is based on the judgment. It is not based on any statistical parameters, not based on any statistical theory. So therefore, you can make qualitative statements because it's based on the judgment, not based on a proper sampling techniques. So therefore, you can't make any quantitative justification of the figures. You can say based on the sample I have chosen, based on my experience, this can happen, this cannot happen. But you can't say I'm 95% confident that this is right. Or else you can't say this is my 99% sure the mistaken invoice value will be in between this. So like that, you can't make quantitative measures of sampling risk, or it does not provide a quantitative expression of sample results. It is not possible, right? At the same time, if the auditor is not proficient, the sample may not be effective. If it is a right auditor with the right experience who has the right judgment, then always it can even be better than statistical sampling. But however, if the auditor is not proficient, competent enough, then this system may not work. So this is what you mean by non-statistical or judgmental sampling and the positives and negatives of judgmental sampling. Any questions on that? Are we clear? Are you clear with the concept? And Can I move forward?
Yes, please.
Yeah. Thank you. And then statistical sampling provides an objective method. So we create an objective method. So objective method and subjective methods are different. Subjective method, say one of you, Prasanga is an experienced auditor, the way you exercise your judgment versus Suranta, who is another experienced auditor, the way he picks the sample may not be the same, but both may be equally valid. But it's based on your judgment. It is not objective. It is subjective to the person who is doing that. Right? But statistical sampling is an objective method. So whether whoever who does it is very much thinking on the same line, right? So more consistent. Unlike judgmental sampling, it is also provides a means of quantitatively assessing the precision and confidence levels, right? So this is the difference between statistical sampling. Unlike judgmental sampling, you can make quantitative estimates, right? Confidence levels or whatever, you can quantify and make comment when it comes to when you do take statistical sampling. So that's the beauty or the positive side of statistical sampling, right? Statistical sampling helps the auditor to design an efficient sample and measure the sufficiency of the evidence obtained and evaluate the sample results based on quantified data. So in this case, it helps all these decisions based on quantified data, not judgment. So picking an efficient sample. Efficient sample is that, say out of a population, right sample size efficient means by picking a lesser percentage of items, you pick a representative sample. By picking a lesser proportion of the items as a sample, if you can still have a representative sample, we call it efficient sample. But to have a representative sample, depending on the method you use, if you are supposed to have a large percentage of the population to be included in the sample, we say it is not an efficient sample. Okay, so you should have an idea of what you mean by an efficient sample. And it measures the sufficiency of the evidence obtained. So you will indicate this based on acceptable level of evidence. And at the same time, you evaluate the sample based on the quantified data. Always is based on the quantified data. Okay, right. Having said that, statistical sampling, it provides always a quantitative measure of sampling risk, confidence interval, and precision. Always there's a quantitative measure. It provides a quantitative expression of sample results. That's the other one. And it helps the auditor to design an efficient sample. So these are the positives. These are the negatives of judgment sampling have become positives of statistical sampling. The following are the disadvantages of statistical sampling. The negatives of statistical sampling. It can be more expensive and time consuming than the non-statistical sampling. It can be more expensive and more time taking than the judgmental sampling, sometimes statistical sampling. It requires special statistical knowledge and training, obviously. You should know statistical approaches. Or else, and at the same time, it requires statistical software most of the time when you take the sample based on statistical approach, right? In some instances, internal auditors may need to evaluate whether the use of historical data or drawing on a new sample is optimal. Some of the internal auditors may need to evaluate whether the use of historical data or drawings of new sample is optimal. So whether it's an optimal sample or not, you may have to do an evaluation sometime, right? So this gives you an idea of what is non-statistical or judgment sampling and what is statistical sampling or non-judgmental sampling. Any clarification of this? Any clarification on this? Can I move forward? Are we okay?
Yes, please.
Right. So what we can do is actually now we will just try to, because this numerical thing, we will try to do a couple of questions. Right. Can you see my screen, Word document? Can you see this Word document?
Yes.
Okay, so shall we try answering down these questions based on what we discussed? I told you certain concept, it's easier to absorb better through the practical application, right? For the type of question. So in sampling applications, the standard deviation represents a measure of what? Standard deviation is a measure of what? Expected error rate, level of confidence, degree of data variability, or the extent of precision achieved. Actually, what I told you, standard deviation measures whether the values are close to each other or whether the values are dispersed from each other. If the values are close to each other, standard deviation is less. If these are dispersed from each other, standard deviation is more. So therefore, if the values are close or dispersed, that is the degree of data variability. So standard deviation always measure the data variability. That is that. Any questions on that? Right. So then I'll go on to the next one. So there is a standard deviation with the variability of the population. So then let's take the next question. In sampling application, the group of items about which the auditor wants to estimate some characteristics is called what? In a sampling application, the group of items about which the auditor wants to estimate some characteristic is what? A population, attribute of interest, sample, or sampling unit. What do you think the answer is? Group of items about which we want to estimate the characteristic is what? Population. Because we want to study the characteristics of a population. So the group of items about which we want to estimate some characteristic, we call it the population, right? Attribute of interest, we are going to discuss it later. But the sample is actually sample is the supposed to be representative group of items that we choose from the population in the sample. And then the sampling unit is when you want to do some sort of a study. What is the sampling units? Is whether you want to do some study about your credit worthiness or something like that, whether you're going to check based on the invoices or whether you're going to do the checks based on the customers. The customer may have multiple invoices, or whether you are going to do the study based on the outcome of a distributor. So like that, the sampling unit is the level at which you conduct the study. Okay, so here what we are studying about is actually the population. Any questions about that? Population is a group of items about which an auditor wishes to draw conclusions. What about this? A specified range is based on an estimate of population characteristic calculated from a random sample. Right? You specify a range based on the characteristics from a random sample. The probability that the range contains the true population value is what? When you take a sample and when you give a range, right, that will contain the probability, when you express probability, that will contain the true population value within that range. What do you call it?
Confidence level.
That is the confidence level. The range, the probability that the range contains the true value, that will be the confidence level. That is the confidence level. Okay. What about this? a 90% confidence interval for the mean of a population based on information in a sample always implies that 90% of the chance that. What do you mean by a 90% confidence interval for the mean of the population? What do you mean by a 90% confidence interval? When you say 90% confidence interval, so that means what?
Is that C?
No, confidence interval actually would attempt that it has nothing to do with the standard deviation. Basically, 90% confidence interval of population means that population means lies within that the specified confidence interval. That is what you mean by 90% confidence interval. True population, we don't know the true population, but we take a sample and based on the sample, we take, say, 90% means certain number of standard deviation above and below, we take that range. So that means there is a 90% chance that the true population mean will be within that 90% confidence interval that you have calculated based on the sample. Because when you take a sample, we will calculate the sample mean value and also we will calculate the sample standard deviation. So therefore, to have the 90% confidence interval, let us say we have certain number of standard deviation, let us say one standard deviation of plus and minus. So that means there's a 90% chance that the actual population mean will be within that 90% confidence interval. That is what it means. Okay.
Sir, what about we say regarding that question?
Sorry?
It's mentioned in the question 90% of the confidence. What about we have 90%, 95%? Still, the answer is same.
Still,
but what I trying to say now in the question it is mentioned on 90% of confidence. Okay. Now we have 3 levels of confidence: 90, 95, 99.
Okay.
So my question is still the if there's a change in
okay, it's like this. Okay, now say let us say you have a population, say value is 100, let us say standard deviation is 10. Okay, you get a sample and you calculate the mean and the standard deviation, and let us say our mean is 100, let us say standard deviation is 10. Okay, from a sample we calculate the mean and the standard deviation. That means you look at, can you see the screen now, this PowerPoint slide?
Yes, please go ahead.
Okay, so now what it means is, now we have a mean of 100 and standard deviation of 10. So standard deviation is 1 means 100 minus 1 standard deviation. This 100 minus 1 standard deviation is 100 minus 10, that is value of 90. 100 plus 1 standard deviation. I'm very sorry, my phone has got this Bixby or something like this activated, so it's always coming. I don't have time to get out of that. So what it means is, you take 1 standard deviation is 90 plus 1 standard deviation is 110. So that means our 68% confidence interval is between 90 and 110. Got it? 2 standard deviation is 100 is the mean. 2 standard deviation is 2 into 10. That is 20. So then 100 minus 20 is 80. 100 plus 20 is 120. So our 95.5% confidence is between 80 and 120. Got it? Or else, if our standard deviation is 10 and mean is 100, 1.64 standard deviation is 1 standard deviation is 10, 1.64 standard deviation is 16.4, which means 100 minus 16.4, which is 83.6, and 100 plus 16.4, which is 116.4. So So that 83.6 and 116.6, that is 90% confidence interval. So we are 90% sure that our population value will be plus 1.64 standard deviation, that is 16.4, minus 1.64 standard deviation, that is minus 16.4. That 90% confidence interval is within that range. So therefore, depending on the confidence interval, we will be choosing the appropriate number of standard deviation. Did you get the answer to your question or not?
Yes, please go ahead.
You're sure, right?
Yeah, thank you, sir.
Right. Okay. Good. So let's move on to the other one. What is the answer to this? One standard deviation corresponds to what approximate percentage of the area under a bell curve? One standard deviation means what percentage of area under the bell curve? One standard deviation is what percentage? That's why I said you have to have an idea. This figure percentage, you can take it from this as well. One standard deviation plus or minus is 68%. Two standard deviation plus or minus is 95.5%. Got it. Three standard deviation plus or minus is 99.7%. That is what you mean. Is that clear? Say the same thing here. Say mu is mean, one standard deviation more, one standard deviation less. So if you take the values, mean is 100, standard deviation is 10. So 100 minus 10 is 90, 100 plus 10 is 110. So 90 and 110, 68.2% of the values are within 90 and 110. Two standard deviations mean 80 and 120, 95.4% of the values are between 80 and 120. 99.7% of the values are between 70 and 130. So that is what it means. Are we clear? Is that clear?
Yes, please go ahead.
Right. So now this, as I said, now what I could have explained to you using so many theoretical points. If you grasp these points that I illustrated to you through this question, this graph, these percentages and the standard deviation, that is all the practical part of it, what you should know, because we are not taking you through a complete logical theoretical coaching here, because it's so many concepts put here and there. But this is what essentially these things mean from practical point of view. Okay, right. So there's another question. So can you just attempt this one? Will you attempt it on your own? See, Jayan, see whether you can find the answer to this. Question number 50. So here, mean value of the sample is 150 and sampling precision is plus or minus 30 at 95%. So here you are not given the standard deviation, but 95% plus minus value, that is standard deviation multiplied by the number of standard deviation plus 1 plus 2 like that. So that range is plus or minus 30. So that means, so 150 minus 30 plus 30, say 150 minus 30 plus 30, that is 120 and 180 is the range at a 95% level. So that means the probability is that 95% that the range 120 and 180 contains the true population. So just because the sample mean is 150, we can't say population mean is 150 because this is just a sample. So therefore, what this theory says is here, if you have a sample mean of 150 and based on a standard deviation, 95% confidence interval is plus 30 and minus 30 between. So that means there is a 95% probability that the true population mean will be between minus 30 is 120 plus 30 is 180. So it will be within this range, 90%, 5%. Probability that it will be within range. Is that clear? On the other hand, 95% probability plus or minus 30 means if you switch to this graph, right? If you switch here, 95% plus or minus 30 is 1.96 standard deviations is 30, right? 195% is plus or minus 30 is 1.96 standard deviation is equal to 30. So therefore, one standard deviation is 30 divided by 1.96. So that is if you want to link everything. If it is given the standard deviation, multiplying this, you get the appropriate value. On the other hand, in this last example, you are given the absolute value without giving the standard deviation, but the absolute value and the confidence interval. So it is, now you would have seen, if you are not comfortable with the statistical concepts, but this application is very, very simple and straightforward. It's all about the confidence interval, the standard deviation, variability, and what these terms mean. Any questions on this? Are you clear? Are you clear? Do you want me to explain further? Right. I think these are the questions that I have chosen. So let's move forward. Right. No directly related questions. So let's move on to the other area of discussion. Right. So this is where we were. Say, remember, this is also same scenario. Say 20 feet is the mean. Standard deviation is 1 foot. So 20 plus 1 is 21. 20 plus minus 1 is 90. 68% confidence interval is 19 feet and 21 feet. Or there is a 68% chance that population mean is 20 feet, but the actual mean is between 19 and 21 feet. There's a 68% chance. There's a 95% chance that when you have a sample mean of 20 and a 95% 0.5 confidence interval is between 22 and 2018 and 22, there's a 95.5% chance that the population mean is between 18 and 22. That is what it means. Are we okay?
Excuse me, sir. I think we started with the number 15. Yes, number 15 slide. Use in that time you said okay, after 30 minutes time we will be okay for confidence intervals. I think in the question also part C it was mentioned confidence level. I think I still not got the interval levels and
confidence interval is the range. That this is the range. When you give a range of values, it is between 120 and 180. That is a confidence interval. You give a range of values, that is a confidence interval, right? And confidence level is 95% confident that it is between this range. The confidence level is that percentage that you attach to. Confidence interval in the range of values. Confidence level is the percentage that you attach to. That is the difference between the two in simple terms. Is that okay?
Yeah, can you go to the question last we discussed and why number C is not correct?
Okay, one moment.
Thank you.
In repeated sampling intervals within in repeated sampling intervals within a precision of plus or 30 around the sample mean always contain true population mean. But why is it wrong? Okay, good question. Why is it wrong? Plus or minus 30 will always contain the population mean. Why is it wrong? Why it is wrong is actually because we can't say it is always contain the population mean. You can never say based on a sample, we can't say anything 100% accuracy. Always, depending on the standard deviation, there is only a percentage only say. That is why when we say bring this value, always either it is 95% confidence, 99% confidence, or 99.7%. But you can always, it is a probability. Just because you pick a sample and we can't give with 100% accuracy, we can't say it is contained within this range. If it has to be 100% accuracy, then it has to be an infinitely wide range, right? So why it is wrong is we can never, based on sample, we can say always contained. What we can say is we have to always attach a probability to that. That is the reason why it is wrong. Is that okay?
Thank you, sir. Thank you.
Okay, so we will just move forward and try to pick different types of questions as well to keep your minds clearer. And again, please get your questions and the doubts clarified as we move forward. Right. So now this is where we discussed about the judgment sampling and we discussed about statistical sampling. Okay. Now we move on to the next step. What is the sampling risk and non-sampling risk? Can you see this PowerPoint slide? Can you see the PowerPoint slide now?
Yes, sir. Yes.
Okay, I'm asking that question because I'm switching between different documents, right? So when we make certain comments or the judgments based on a sample, our comments may not be accurate all the time due to two reasons, two types of risk. One is the non-sampling risk. The other one is the sampling risk. Okay, the comments or the judgments or the conclusion that we come to based on the sample will not be 100% accurate due to two types of risk. One is the sampling risk. The other one is non-sampling risk. Two types of risk associated with that. If I first take what is sampling risk, sampling risk is a risk that a sample is not representative of the population. That is what you mean by a sampling risk. You may pick a sample, right, and try to make a conclusion, but you may not pick the right representative sample from the population, and then you come to a conclusion, incorrect conclusion. So that is the sampling risk. That can happen because you have not picked up the sample in the more appropriate proper judgment or using a proper statistical method. Or else you may have used the correct method, but the sample size may not be good enough. So whatever the way, you pick the wrong sample and come to the conclusion. So then that is sampling risk. Say for example, you want to study about the study patterns of the students, right? Or the intelligence levels or the competencies of the students. you pick the students from the last row of the class and you take that as sample. So then that may not be representative. There are certain types of students who may sit at the last row. There are certain other types of students who will be seated in the middle of the class or front of the class. So therefore, your sample is not you have not picked the sample in the right manner. On the other hand, you have a class of 100 students in a university lecture hall. You get 3 students as a sample and you try to make conclusion. So then the sample size is not big enough. Whatever the way, it is due to the sampling process, you don't come to the correct judgment. It is sampling risk. Statistical sampling allows the auditor to quantify the sampling risk. So when you do a statistically correct sample, always the sampling risk can be quantified. You can say there is a 95% chance that this is representative, still 5% of the chance that your judgment may not be right. An auditor should never attempt to quantify the sampling risk of a non-statistically drawn sample. If it is a judgmental sampling, you can't quantify the sampling risk. That is, we said, no, initially, if it is a quantitative statistical sampling, we can quantify. Non-statistical sampling, judgment sampling, we can't quantify. Okay. The other one is the sampling risk is inversely related to the sample size. What it means is, the bigger and bigger the proportionate size of the sample, chances that you may have picked the wrong sample is less. The bigger the sample is, whatever the method you use, your sample may be more representative. On the other hand, the smaller the sample size, whatever the method that you use, that may not be good enough and that may not be representative. So that is what it says. Sampling risk is lower when the sample is big. Sampling risk is higher when the sample is smaller. So that is why it says inversely related to the sample size. Are you clear with the idea of sampling risk or not? Is the idea clear? Not picking the right sample. Are we okay? I'm not hearing anything. Are you okay? Is the idea clear about the sampling risk?
Yes, okay.
Hello?
Yeah.
Right. Okay, good. Non-sampling risk is something else, right? You may pick the sample in the correct method, right? But you coming to a wrong judgment is not because of the fact that you took the wrong sample, but it may be some other failure of the audit process. For example, we may try to see whether the correct authorization of a document, for example, and to do that, we may pick the right, using a right statistical sampling technique, we may pick a right size sample. So there is sampling risk is minimized. But however, the auditors towards the last day of the audit, right, 10 o'clock in the midnight, you get the auditors to do this test. And they are so tired and sleepy, so they have not done their testing properly. They have not properly checked the points rightly. So due to the fatigue of the person who is doing that, you pick the right sample, but you did not follow the right process. Or else, probably that person may not have been trained to do the verifications properly. Okay, that person may have not followed the indicated procedure to see whether the authorization is right. Say, for example, there were 5 points that you were supposed to check, 5 points of authorization that you were supposed to check to see whether the authorization is complete, but he checks only 3 points. He does not check everything. Okay, so due to fatigue, oversight, negligence, improper training, or not following the audit procedure, whatever it is not due to the process of selecting the sample, but checking the document or whatever the procedure. So then you are not making the correct judgment. So that is the non-sampling risk. So I hope you are clear with the idea of what is sampling risk and what is non-sampling risk. Are you okay? Is the idea clear? Sampling risk versus non-sampling risk. Can I move forward?
Yes, sir. Please.
Okay, right now you will see in each one of these slides, there are a couple of points that you learn, and each one of these points can come for a question from your examination point of view. So therefore, be very clear that you get the concept right, whatever that you learn within each of these slides. Okay, so let's move on to the next slide. Selecting the sampling approach, how to select a sample. So we are going to learn the basic principles about selecting a sample here, and then thereafter we are moving into some other aspects as well, right? So let's come to this, selecting a sample, right? I see participants dropping. I have see only Prasang and Surant, others have dropped. Why is that? Am I making it too boring?
No. I think they have electricity problem.
Is that right? Okay. Okay. Right. So let's see how we choose sample. Now here we are going to look at how to pick a random sample, right? So what you mean by a perfectly random sample, right? What you mean by a perfectly random sample is that when you pick the sample, each and every sample has an equal chance of getting chosen in the sample. So then we call it a random sample, right? If each and every sample has equal chance of being, or a proper chance of being included in the sample, right? So then we call it a random sample. But if some of the items have a lesser chance of being included in the sample, so then it is not a random sample. Let us say there is a bowl of items, and where you're going to put your hands and pick it, and the person who is going to pick that bowl stirs all the balls properly and pick the item. So then there's an equal chance of each and every ball to be selected. But if you don't stir it properly, and if that person picks one from the top, so that means the bottom level, whatever that is there at the bottom level, does not have a similar chance of getting selected. So then it is not a random sample. So each and every item has an equal chance of being included in the sample. We call it the random sample. Okay. Number one, if enough large random samples are drawn, mean of their means will approximate the population mean closely enough that they are considered to be representative of the population. This is, of course, the concept-wise, just read this clearly. When we say is, when you pick one, this means this carefully, when you pick one sample and calculate the mean, right, that one sample mean may not be representative of the population mean. It is still a sample. We are only picking some items only. But however, if we pick enough number of good enough random samples, if we pick a lot of samples, and each sample will have a different mean depending on what are the items included in the sample, because you take one sample from one area, another sample, another sample, another sample. Each one of the samples will be different, so the sample means will be different. But however, if we pick good enough sample, all the sample means when we calculate it, the sample means mean. The individual sample will have mean. All the sample means also we calculate an average. That sample mean will be representative, very much close enough that they are considered to be representative of the population. So therefore, if we have the large enough random samples and we pick so many different random samples, and the mean of all the sample means will be representative of the population mean. So just is an idea, that's all. For very large population, but this point is very more important. For a very large population, the absolute size of the sample affects the precision of its result more than its size relative to the population. Thus, above a certain population size, the sample size generally does not increase. So the point is that you can't make a judgment based on a very small sample. but sample has to reach a particular size, a certain threshold level, right? And then when the sample population is bigger, our sample, the number of items to be included in the population also should keep on increasing, right? The bigger and bigger the smaller population, if it is a 40 student class, right, you can have a 10 student sample probably. But if it is 4,000 student class, so sample of 10 is not good enough, probably we need to have 100. But then if it's a 4,000 student class, probably 100 is not good enough. 200 sample size has to be there. So when the population is bigger, the sample size also should be bigger. But then provided that the sample size is say 100 units, beyond a particular level, even though the population is very big, the sample size should not keep on increasing indefinitely. So the sample size matters up to a particular level. But even if it is a very big population, so if we have a certain minimum absolute size, we are not going to discuss what it is, of a sample, so then that will be good enough. See, very large population, the absolute size of the sample affects the precision of its result more than the size related to the population. Absolute size matters. How many items are there in the sample matters. So above a particular population size, sample size doesn't have to increase. Still, that is why some of these surveys that we do, if you do research and etc., academic research or some consumer research, say sample size of 200 is good enough. Even if the population is 100,000 or 200,000, still 200 size sample is good enough. Sometimes they say. That is because beyond a particular level, sample size doesn't actually, relative size doesn't matter. This absolute certain size threshold level will be good. That is what it means. Okay. So this is an ideas about random samples. The traditional means of ensuring randomness to assign a random number to each item in the population. Random number tables are often used for this population. I'll show this to you. Random number tables contain collection of digits grouped randomly into columns and clusters. After assigning numbers to the number of population, the tables can be used to select the sample. I will explain you this process through an example. But you have an idea what we mean by a random sample. So if each and every item has an equal chance of being included in the, if each and every item in the population has equal chance of being included in the population sample, we call it a random sample. For that, we said we use what we call the random number tables. We use what we call the random number table. If you just Google and you go to Google and you Google that, then you will see some sort of random number tables like this. Are you okay? Do you see this sort of table? You see what's the screen. But how we are going to use that is, let us say, we will have to pick, say, 25 items in the sample. Let us say a certain number of items in the sample, right? And altogether, say there are 100 items. There are 100 invoices that have been raised in the month of September. Out of these 100 invoices, now you are going to pick a perfect random sample of invoices. From 100 invoices, you are going to pick a perfect random sample, let us say, of 10 invoices. So the first thing is that whether it is 1 to 100 or whatever, all the invoices will be numbered. All the invoices will have to be numbered. So that happens most of the time. We will be having a sequentially numbered set of documents, right? When we have that number, so we are supposed to, they are numbered from 1 to 100, right? They are numbered from 1 to 100, and we have to pick out of these 1 to 100 numbered items. Let us say we have to pick 10 items. Okay, out of these 1 to 100 numbered items, you have to pick 10 items. Then what we will do is, if we have a random number table like this, we can start from random place, right? Let us say, no, I will, to make it more, not clear, more practical, let us say there are 50 items, not 100 items. Out of these 50 items, because I can illustrate some other concept as well with this, out of these 50 items, I am going to pick a sample of 10. Is the question clear? I have a population of 50 numbered invoices, and out of that 50 numbered invoices, I have to pick 10 invoices. Okay, is the question clear?
Yes, please go ahead.
What we do is we go to this random number table and we can start from some random place. Let us say I'm going to start from this place, right? I'm going to start with this number. Let us say here. Say I'm going to start from here, 95. I'm going to start from here, 95. So now I have to pick a 2-digit number. I have to pick from 1 to 50 numbers items. I have to pick 10. So if I pick these two items, if I pick this, the value, the first 2 digits is 95. But I don't have an invoice numbered 95. I ignore that. Then the next digit, 2-digit number is 86. And I don't have any invoice numbered 86 either because I have only 50 invoice. The next number is 32. 32. So then I have to pick the invoice number 32. And then the next one is note 7. 32, after 32, note 7. That means I have to pick the invoice number 7. Is there a number? Yes, invoice number 7 I can pick. And then I have the number 90. But do you have an invoice number 90? Do I have an invoice number 90?
No, we have only 50.
50. So you ignore that. And then we have the invoice number 65. Do we have an invoice number 65? No, we ignore that as well. Then do we have invoice number 30? Say then you will pick the invoice number 30, invoice number 45, 51 we don't have, ignore that, 89 we have, ignore that. So like that we continue. You can start at a random place and we can go horizontally, vertically, whatever the way that you want to do it. So then you can get it, right? If the number is that appropriate number is not there, you can ignore that, but we need to have a sequentially arranged number items. We are going to do it. So if one of you, if Suranta start from 95, this number, you will get one set of invoice. And if who is our Prasanga, you start from somewhere here. If you start from somewhere here, you have a different sample. So depending on where you start, the sample will be different and the conclusions will be different. And certain samples still may be, even though you use random sample, let us say if the sample size out of this is 5, it may not be representative. But if the sample size is 10, there's a greater chance of it being representative. If the sample size is 15, there's still a better chance of being representative. So the bigger and bigger the number of items included in the sample, the greater the chance that it can be representative. But bigger the sample value, our accuracy will be high, our confidence level is high, but you need to spend more time because higher proportion of items included in the sample is efficiency is less. Because you are picking, if you use the proper sampling method, what your objective is, population, pick the smallest possible sample, which is still representative of the population. So that is our challenge, because the bigger the sample is, it is time and cost is higher. Are we clear about picking a random number from random numbers from a random number table? Is that clear? Are we clear? How to pick a random number sample from a random number table?
Yes.
Okay, so we can do it using a random number table, or we can do it using computer Excel. There is a function to generate random numbers. You give the values and the sample size of the sample and all that. Still, there is a way to do that. There are plenty of methods, but just to get a flavor of what it means. Okay, so I have just completed the discussion on what you mean by simple random samples using random number tables. The next one is what we call it interval sampling or systematic sampling. Right? What do you mean by interval sampling and the systematic sampling? We'll read it together and I'll explain what it is. So the systematic sampling plan assumes that items are arranged randomly in the population. If they are not, a random selection method should be used. The first thing is that when you pick a sample, right, you need to ensure that the items are randomly arranged in the sample. So the value of the invoices as it is. Let us say you sort the invoices from the smallest value to the highest value, or the largest to the smallest, or the smallest to the highest. So then you pick this, you apply the interval sampling method, it is not right. So all the population values should be randomly organized, not in a manner that you have arranged according to a particular order. The way they arise randomly, it has to be there. Simple random sampling, we said sequentially numbered items have to be there because you are picking the number and pick the appropriate one. Here, they should be completely randomly arranged, organized, right? Interval sampling divides the population by the sample size and select every nth item after random start in the first interval, right? It is too technical, this term. Very simply, what it means is an absolute simple thing. Just say there is a population with 1,000 items. There is a population with 1,000 items. There are 1,000 cash payment vouchers. And your statistical guideline, according to your statistical guideline, your sample size is 35, right? Based on your sampling method, your sample size is 35. And you decide to use systematic sampling method. You decide to use systematic sampling method, right? So using systematic sampling, not random sampling, systematic sampling. Random sampling, we pick the based on the random number. Systematic sample, so out of 1,000 items, you need to pick 35 items. So which means 1,000 divided by 35 is 28.57. 28.57 has to be the interval of sample selection. Because why? Out of 1,000 items, you need to pick 35 samples. So which means 1,000 divided by 35, every 28th item has to be selected. Okay. So then when you want to do that, what we simply do is we have all the items. So first item, because every 28th item we need to choose. Then you can, the first item can be anything between first item and the 28th item. Right? First item can be anything between first item and the first and the 28th invoice. Let us say randomly you have chosen 10th item as the first item. Right? The first item you randomly, because between 1 and 28 you can pick any of the items because every sampling interval is 28.57. So between 1 and 28 we can pick the first sample. So first sample will be, let us say 10. Thereafter, every 28.57th item you are going to pick. So if first one, the 10th item you will choose first. And then the second one is 10 plus 28.57, that is 38.57 is the next item that you're going to select. And then you are going to select 38.57 plus another 28.57, 48, 58, 66 item. And then you add another 28, 76, 86, 94th item. So like that you keep on choosing the item. So therefore, they are all randomly distributed items. So every 28.56 or 28th item you are going to choose after starting within the first 28 items. So that is what you mean by interval sample. Is that clear? Are you clear with the way you pick the sample or not? Interval sampling. Please get it clarified if it is not clear. Are we okay?
Yes, from my side.
Right. Okay. Now let's say, for example, before I go to this, if the population contains say 8,200 items and the sample of 50 is required, so that means 8,200 divided by 50, that is every 164th item has to be selected. Every 164th item has to be selected. So your first item, you can choose anything between first and 164. For example, the first item chosen is the 35th item. So that is the first item that you're going to include in the sample. Then the interval is 164. The second item is 35 plus 164, 199 item. Third item is 199 plus 64, that is 363rd item. Like that, you continue adding 164 all to the starting point, and you pick the relevant items until you pick the sample of 50. So by the time you reach the entire 8,200 large 164 items, then you pick one from there, your sample size of 50 will be completed. So that is your sample. That is what you mean by interval sampling. Is that clear?
Yeah, I can. I don't know whether this is a mad question. In a random sampling, we can put ascending or descending order and pick the sample. But how to mix it in for this interval sampling? It should be as it is, not in the sequential order. I don't know how to do that one.
No, because now it is as it is. Now say that you don't have to do anything then. Why? Say you have to pick, say some, let us say you have to pick, say there are big inventory, 1,000 different inventory items, right? So then you have these items. So then you are not arranging them in a particular manner. Say then you get a listing of your inventory out of your inventory report, and then the way it is, you are going to pick them. You're not going to arrange them in any particular size or any weighted order. The way it is, you are going to pick the items. Why? I don't know whether I understood your question or not. So again, just
in a warehouse one. Let's say if I go and ask in warehouse manager, okay, give me a list of inventories you have, then he will give. Right. Maybe he will give on ascending order. Maybe he is giving on the order that they have placed. Maybe the similar nature of item they have stored in the same place. I think that's also in a sequential order.
Yeah, so then that will be no. Then if it is if it is arranged according to a particular order, so then it is difficult. So actually, you have to look at how these things are arranged. If it is because if it is systematically arranged in a particular order, so then it may not be representative by when you select it. Most of the time, I think in a situation like this, like the situation that has been illustrated here, say for example, there are certain documents, I think not all the times this method may be appropriate. Certain sampling methods may be appropriate and practical in certain types of instances and may not be practical in certain other types of instances. Now, this type of scenarios, if that is the case, definitely is very likely that this particular sampling method may not be the right method. But let us say you have certain documents which you are arising over a period of 1 month, over a period of 1 year. Like you have items like that. And then you want to have select the sample in such a manner, the way they arise, like say all 12 months, the sequential order will have to be represented. So in which case, if you use something like this simple systematic sampling, you pick the first invoice in January up to the last invoice in December, you pick interval sampling and you pick these items. So then it is a good chance that the transaction that happens within every part of the year will be season, off-peak, off-season, January, December, holidays, whatever the way, all the items are going to be selected. Or else you're going to see whether the accuracy of authorization, 24-hour operation, whether it is related to the time that you do the transaction. So then let us say you the first transaction of the day, the last transaction of the day, you have them in that order. From that you pick the systematic sample. They are not arranged in a particular order. So then when you choose this method, you get the right sample. But if the items are arranged in a particular order, so then that method may not be the right method to pick the random sample, because then not the situation to apply interval sampling, because in that case it is already arranged and then it is difficult to break that arrangement. So therefore this method may not be the most appropriate method. That's probably the answer that I can give you. See whether the controls are operating throughout an entire year, right? So if you pick a random sample, let us say in that exactly the example that you're giving, if you pick completely random sample, there is no assurance that the invoices or the vouchers from all the months are going to be selected. But the way the items are there randomly depending on the way you get the transaction. So then you pick these items, right? So then there's a good chance that all the entire year's transaction may be reflected in your sample, some or the other. So in a situation like that, this may be a good method, but in a more structurally arranged data, if it is already structurally available, so then it may be not the right method to pick the sample in this manner because it may not be represented. Are we okay?
Yes, thank you, sir.
Right. So this is that interval sampling requires only counting in the population, no correspondence between the random numbers and the items in the population is necessary is as in random number sampling. So that is interval sampling. And then, one moment, then we move on to the third one under this. The next one, what we call the block sampling or cluster sampling. Cluster sampling also, there are a couple of different methods. In cluster sampling, we randomly select groups of items as a sampling units rather than individual items. An example is the inclusion in the sample of all cash payments for May and September. Only possible disadvantage is that the variability of the items within the cluster may not be represented by the variability within the population. Here it's like this. Now, say for example, you want to pick
Sorry,
items.
sir. I think we missed the presentation.
Yeah, sorry about that. Can you see this now?
Yes, thank you.
Okay. Now, say here, let's say these are the transactions happening within the month of January, February, March, April, May, like that. These are the transactions. Let us say the employees leaving the organization. You want to do some sort of a survey. January, February, March, April, May, June, July, August, like that. We are going to do this survey. So now what we will do is what you mean by cluster sampling is that, so January transaction, so January employees in January is one cluster. Employees leaving February is another cluster. Employees leaving in March is another cluster. So like that, these are arranged into the clusters. So then what we do is, now in random sampling, out of all the employees only, we are going to randomly choose, select them. That is random sampling, right? Employee numbers or whatever, from that you will be choosing. In interval sampling is that you have the list of employees who are leaving in the same order in which they are leaving, the first employee to leave in January 1st, and all the employees in January, February in that order. So then in the interval of, at the systematic interval, you pick them. So then it is an interval sampling, right? So then the cluster sampling is where you're not going to do it either of the way, but let us say you have, say, 12 months of employees who have left. Out of that, you will choose certain clusters. Let us say you choose the employees who are left in January, February, May, and September. Right? January, February, May, and September. So out of the, if the data is organized into a couple of clusters, you pick a couple of clusters, right? And then once you pick the clusters, more likely that you will be choosing all the items within that cluster. You may be choosing all the items, all the employees who have left in the month of January, all the employees who are left in the month of August, and say all the employees who are left in the month of October. And then you choose. So out of these different clusters, you pick one cluster or couple of clusters, and then you use that as a sample. So that is what you mean by the block sampling or cluster sampling. Is that clear? Only thing is, when you pick that cluster, because you say here, they say you pick the May transactions or May employees and the September employees. But May and September may not be representative months. May and September may not be representative months. So therefore, when you pick a cluster, if that cluster is not representative, picking certain clusters and doing the study may not be giving you the right representative sample. But this is also another approach to sample. So we discuss about 3 approaches: simple random samples, right? And then systematic random or interval samples, and thirdly, cluster samples. So these are the 3 sampling methods that we have discussed so far. Any questions? Are we okay? Can I move on to the next one?
Yes, please.
Yeah. So, okay, before I move on, like, how do you think of this area, the what we cover and how we cover? Just give your comments, like, because we see less participation in the class. Why you want to give any feedback or any comments? I think Priyanka, Prasang or Leo there. I think Vivian is also there. Any comments? Any open comments?
Yeah, no, not to worry about the participants. Actually, in other days also we have few participants, but at the beginning we have 5 numbers. But dropping the number will not indicate that your lesson is not so much attractive. So not to worry about that one.
Okay. Anyway, if there are comments, just
power cuts, people have some commitments. I don't know, because of that one, I think since the recording also available, people, I think, yes, that's not the indication about the attractiveness of the class.
Right. Okay. Thank you. Now, because we need to ensure that whether we are going it right, because it's not an area that not every one of you will be familiar also, because this, unlike your normal common sense things to an auditor, statistics is not something very directly integrated with your work. So sometimes this area that I'm going to teach with you may be a bit distance from your day-to-day work, but still it is important for you to have a complete knowledge in this area. So let's see anyway, if there's any feedback, just let me have that feedback. Right. I'm also trying to go a bit slow, because you can't explain some of these concepts just very fast. So I had to take a little time. So that is why I'm going a bit slow as well. Okay. There are 2 other concepts actually which I want to take you through today. One is that normal statistical plan. What are the steps involved in a basic steps involved in a statistical plan? Right. So now these are the things that we have to be considered. These are the steps. You need to have some general sense of how you will develop a statistical plan, right? First of all, you need to have an idea of the objective of the plan. Why you do this, right? Say, for example, if it is a test of controls, whether the authorization is right, or whether collections are happening on time, or whether the inventory is outdated, or whatever it is. So it is a test of controls, right? So then example is to conclude that the control is reasonably effective or not, whether a particular condition is satisfied or fulfilled or not. Approval, authorization, obsolete, whatever, a particular control is satisfied or not. So this is something to do with an like discrete variables, attributes we are checking. That is what we are looking at there early in the first lecture. For a test of detail, then it is not about a control, yes or no, or conditionality that you are looking at, but then it is about an amount, right? A value, maybe days, maybe monetary values or time or whatever, it is a value. So therefore, first of all, we need to have an idea what is the objective of this study or investigation. That is number 1. Number 2, once you have an idea about the objectives, the next thing is that you need to define the population right? Defining the sampling unit, an individual item in the population, and considering the completeness of the population. So then one thing is you need to have an idea about the population, right? The population from which you are going to pick the sample. If it is inventory items, so then you know the population is clear. Right? If it is your customer invoices, so your population is clear. Your payment vouchers, your population is clear. Right? But say somebody who is doing a study about the street children who are abused to drugs, who are using drugs. So then, is your population clear? Or the beggars on the road, is the population clear? Do you have a population? You know what a beggar is, but do you have a record? Your inventory items, you have a record. Your vouchers, your invoices, or customers, you have a record. But if it is the beggars or street children, no street children who are using drugs, we don't have a record. So therefore, whatever it is, you need to define the population first. Right? So it's a very broad man, I said. Then you may say these are the payment vouchers, the cash payment vouchers raised within the first quarter, January to March. So then that is your population. Right? Or else the delayed payment settled invoices, settled with a delay within the second quarter. So like that, first you need to define the population, then only you will be able to pick the sample. That is number one, right? So if it is a control, yes, no approval type of scenario, right? So then it will be, you will be looking at the period that you are going to look at. First of details, the values, the significant items individually, significant items may be defined. So we will look into that later. So that is, but you need to first identify the population and also sampling unit. You need to define the population and the sampling unit. What you mean by sampling units is simple example. You are going to study the settlement patterns of all the invoices. Your sampling unit can be each and every invoice, can be a sampling unit. Right? So you go to the invoice level and you pick samples of invoices. On the other hand, there are certain customers and each customer may have a number of invoices. So instead of giving a random chance for each and every invoice, so then the sampling unit is invoice, you may be picking the customer, and when you pick the customer, automatically you will pick all the items of that customer. So then your sampling unit is customer, not invoice. Okay. So like that, or else let us say you have thousands of distributors in a big country, right? Each distributor may have a number of customers and each customer may be having number of invoices. So then you are going to pick in the sample distributors, right? So that means it is the distributor is the sampling unit, not the distributor under customer under distributor, or the invoice within the distributor's customer's particular invoice. So then your sampling unit is the distributor. So therefore, at a different level, you need to define the sampling unit first, right? So that is defining the population and the sampling unit is very important. And then determine the acceptable sampling risk. Sampling risk is basically you want to come to a conclusion with a 5% chance that your conclusion is wrong, can be wrong. With a 10% chance, your conclusion can be wrong. So like that, you need to accept a particular level of risk. Because if you want to make a judgment saying that all these invoices are properly authorized, like the question that you asked earlier, we can say there is no risk. I'm 100% sure that the invoices are properly authorized by checking this sample. You can never be 100%, right? But then you can say you can be 90% sure or 10% chance that your conclusion may go wrong. You may say that the invoices are properly authorized. Or 95% chance that only 5% chance that your conclusion may be wrong, you may say that the invoices are properly authorized. So like that, you need to decide on the acceptable level of risk. Of course, anyone would like to do the investigation with the least possible level of risk. But if you want to minimize the risk, on the other hand, you have to increase the sample size. So if you are going to increase the sample size, you need more resources, it's more costly, it is going to be more time consuming. So therefore, layman's point of view, you would like to have the highest level of confidence or the minimum risk. But you can't do it practically because when you try to minimize the risk, the sample size has to be bigger and bigger, which is not practical. So therefore, always depending on the significance, criticality, and then the repercussions of not making the correct judgment, you may decide to make the investigation accepting a particular level of risk. Say high value cash transaction, the level of risk that you want to take may be very small, maybe 1% chance of going wrong. But is low value inventory items, you may be even willing to take a risk of 20%. That is 20% chance that you may be wrong, still that level of risk may be acceptable. So like that, you need to decide on the sampling risk. Okay. And then you have to look at the sample size using the tables or sample size formula. To little extent, we are going to touch upon that here, because you need to decide when you want to do a study, you need to decide on the sample size, right? Say you are going to look at cash payment vouchers of 100,000 cash payment vouchers. Are you going to pick 20 cash payment vouchers or 30 items or 200 items? So therefore, like that, so you need to decide on the sample size. To do that, either you can use a formula or else you can choose, there are tables which will give you, depending on the level of risk you want to take, the population size. This is the sample size that you are going to pick. So therefore, you need to pick the sample size. In some cases, it is efficient to divide the population to subpopulations or strata, right? And then we do what we call stratified sampling to minimize the variance. Do you have what you mean by an idea? What you mean by stratification? Let us say you are doing an investigation. Let us say you have 3 types of customers: retail customers, SMEs, and large corporates. There are 3 types of customers, and your invoices are coming from all types of customers, right? And then let us say 40% of your customers are small customers, individuals. Another 30% are SMEs. Let us say 20% are large corporates. Like that, say 50%, 30%, 20%. That is how your customer distribution. And when you do a study, you want to ensure that all these categories are represented adequately. The retail, the small timers who are 50%, SMEs who are 30%, and large corporates which are 20%. If all of them are to be included in your whatever the sample that you choose, one thing is that you can pick a big sample, big enough sample, very big sample. Then you are ensure anyway that small, medium to large customers are all adequately represented in the population. Okay, but on the other hand, to do that, you need to have a fairly big sample. The other thing that you can do is, 50% of your customers are small customers, 30% are medium, and 20% are large. So therefore, when you pick the sample, 50% of the sample will be from small customers, 30% of the sample will be from medium customers, 20% of the sample will be from large customers. So that is your stratifying, and from the stratified lot, you are going to choose it. So then with a relatively smaller size of sample, still you get the representation of all these categories. Okay, that is what you mean by stratification. Stratification also allows the auditor to apply more audit effort to larger elements or more risky parts of the population. Another thing is, if you have to be equally representative, you can do that. On the other hand, once you stratify that, if a particular stratification is more significant for your study, so then you can focus more on the more important stratified segment. That is what it means. Right? Say, for example, when auditing sales revenue, an auditor could divide the population into stratas of dollar increment. The auditor could test transactions under value 500, transaction between 500 to 2000, and transaction 2000 and above. One way of stratifying. Depending on the magnitude of the transaction, you put them into category. So from each magnitude, you will be representative, or high value segments, you want to pick more. Whatever the way, stratification is that, where you have multiple categories and you need to have whatever desired representation from these different categories. That is what you mean by sample stratification. So we looked at deciding on the objective, the population and the sampling unit, what is the risk that you want to take, right? Then what is the sample size, and what is the sampling method. We looked at 3 sampling methods so far: random sampling, interval sampling, and block sampling, right? And then you pick the sample, right? You pick the desired invoices, you pick the inventory items, okay? Like that, you take the sample using that method, and then you evaluate the sample's results. You measure, evaluate, you check all the proper authorizations or whatever. You evaluate the sample and draws conclusion. And once you do that, you document the sampling procedure. So this is basically statistical plan of conducting a study. So you have to have a reasonable idea of what are the steps available in a study like this. Is that clear? Are we okay? Right. It is 8:24. I think I will look at one more concept. Depending on the time and how fast I can explain, I will go to that step as well. About attribute sampling. So can I take about another 5 to 10 minutes with you? Prasanga, Vivian, are we okay? Hello?
Yeah, okay.
Yeah, Vivian, right, thank you. So I in the very first time we had the lecture last week, we said if it is a continuous variable, we have what you call variable sampling. It is a discrete variable, we will do what we call attribute sampling, right? So in attribute sampling, what you are going to do is we are trying to look at attribution, a particular attribute, a particular characteristic, overdue or not, authorized or not, properly approved or not, collected on time or not, obsolete item or not, write-off items or not, inaccurate data entry item document or correctly data entry document. So like that, this is an attribute that we are trying to look at here, right? So attribute sampling generally used to test control, right? So we are trying to see whether the outcomes are compliance or non-compliant, whether they adhere to particular set of conditions or not adhere to particular set of conditions. So that is what you mean by attribute sampling. We do attribute sampling for discrete variables. Number 1. Okay. Now, then the simple thing that we are going to look at is now here I am going to discuss with you what are the factors, aspects that you are trying to look at when you look at the sample size. It's a very simple thing, right? Just go with me. There are 4 factors that you need to consider, right? The confidence level or the percentage time that the sample is accepted to be representative of the population. Greater the confidence level, the larger the sample should be. That is obvious. You know, when you just think open-minded, when you have a population, if you want to make a prediction with a high level of confidence, the lower chance that it may go wrong, to predict with higher level of confidence, you need to have a larger sample. If you have a smaller sample from a big population, you can't confidently make conclusion. But if you pick a large sample from a population, you can be more confident in making your conclusion. So therefore, the higher the confidence level required, the bigger the sample size should be. That is number 1. For a test of controls, the confidence level is the complement of the risk. So if that is the other thing, the higher the confidence level required, bigger the sample should be. So higher the confidence level is lower the risk. Obviously, no, if you are going to predict something with higher confidence level, so that means that's very low risk in that judgment. But if you are going to make a conclusion with higher risk, so then your level of confidence will be less. So therefore, confidence plus risk added together is 100 basically. Confidence level is 100% minus risk. Risk level is 100% minus confidence level. Right? So the most important point is that higher the confidence level, bigger the sample should be. Okay. Number 2, when you take the population, the larger the population size, the larger the sample size should be. The bigger the population, bigger the sample should be. Right? If it is a population of 100 items and you're going to pick a sample, versus 1,000 is the size of the population you're going to pick the sample, or 100,000 is the population where you're going to pick the sample, the bigger the population, the bigger the sample should be. Number 1. However, beyond a particular size of population, you still, I explained to this earlier as well, beyond a particular size of population, the sample size, it doesn't matter. So up to a particular level, size of the population, the sample size should keep on increasing. But once the sample size is good enough, reasonable amount, depending on the studies, then even if the population is much bigger, you don't have to keep on increasing the sample size. So 2 points we looked at. Greater the confidence, lesser the risk, the sample size should be bigger. The lesser the confidence and higher the risk, the sample size can be smaller. The bigger the population, sample has to be bigger up to a particular level. Smaller the population, the sample can be smaller. Right? The second one is that you are trying to check for controls. Like say you are going to check the controls. If you feel that the non-compliances are bigger, the expected deviations are more. If it is going to be non-compliance rates are going to be higher, so then you have to pick a big sample for you to be comfortable. But if the non-compliance rate are smaller, so then you can pick a small sample. Right? So if it is more problematic scenario, the non-compliance levels are higher, so then you need to have a large sample. But if the non-compliance levels are lower, you can pick a small sample. So that is what we mean by the expected deviation rate. And on the other hand, the chances of the making a mistakes, the tolerable deviation is higher, right? Then you can tolerate, even if it is not conclusion, if it is, that is still you're okay, even if a higher level of improper judgment is okay, then you can work with a smaller sample. But you have to be fairly certain about the accuracy. Your tolerable mistake is smaller, your level of tolerable mistakes are smaller, then you have to pick a large sample. Right? So therefore, there are 4 aspects that you need to consider when you pick the sample size. Higher confidence level, lower risk level, the sample should be bigger and vice versa. Population size is bigger versus lower. The bigger the population, the bigger the sample should be up to a particular level. The expected non-compliance is higher, the sample also should be bigger. And the tolerable mistakes or the deviations are higher. Tolerable mistakes are higher, the sample size can be smaller. But the tolerable deviations are lesser, then the sample has to be bigger. So those are the 4 conditions that you need to consider when you decide on the sample size of discrete variable. Right? This is what it explains. The higher the confidence level increases, the sample size also should increase. You want to come to conclusions with higher confidence, the bigger the sample should be. Expected deviation are higher, non-compliance are higher, then the sample size should be higher. Tolerable deviation, acceptable deviations are very high. You are okay to make incorrect judgments, higher level of incorrect judgment, then even if a smaller sample is okay. If your confidence level is less, the sample size also can be less. If the expected deviation is rate, a more compliance sort of population, the sample size also could come down. If the acceptable deviations, problems are lesser, so then the sample size should increase. So now this sort of a thing is directly geared to us from examination point of question. So you may be given a couple of these combinations there. In what scenario the sample size should increase? In what scenario the sample size should come down? So like that, the question may be asked. So therefore, be comfortable with that. I think we have come close to 8:35, almost 8:35. If you have any questions, you can get them clarified. If not, we may call it a day today. Any questions or clarification? A similar discussion, we have done it for attribute sampling, the controls or the condition, but similarly for variable sampling also, we will go through a similar discussion next time we meet. Okay, and I very much want you to go through these slides and come before you come for the next lecture, because this is a bit distant, I know, from what you do on a day-to-day basis as an internal auditor. But if you go through this from questions point of view, also, if you get the concept right, there are more straightforward questions which you can do very easily. So spend some time before you come for the next lecture. Okay. So we'll call it a day with that then, Prasanga.
Yes, sir, I'm here.
Yeah, any particular comments, Prasanga?
No, thank you, sir.
Right. Okay. So any feedback, just give, and I will try to. I like I told you, I went a bit slow because things you need to understand carefully. So next week probably I will try to finish this session with the next week's lecture. Okay.
Okay.
Then.
Thank you, sir. Thank you. Bye. Good night.
Okay. Thanks. Good night. Good night, Prasanga.